Chapter 9, Thinking, Language, and Intelligence. In this chapter, we're going to get to explore some really interesting ideas and concepts about how we solve problems in our day-to-day lives, how language is developed, and how we understand and measure the concept of intelligence. We're going to spend a little bit of time understanding some of the basic components of our solution process. This field that we're going to be learning this from is cognitive psychology. So when you hear cognitive, you should be looking at the idea of thinking. So a cognition is a thought that we have. So when you look at cognitive psychology as a field, right, it's going to be about this mental process, thinking, language, memory, but as well reasoning and judging. We're going to take information that we have kind of gathered over our lifetime and use that information to create kind of a concept, a category of information that we are familiar with. Right, one of the benefits of kind of the longer we live and the more experience we have is that we get to kind of create categories of lots and lots of different types of objects and things that we encounter daily. So whenever we walk into a room, we don't have to sit there and investigate every item in that room and say, oh, this is a chair, or this is a bed, or this is a television. We kind of very quickly can kind of pick up on that information based on our prototypes of that type of item or whatever we're seeing. Some items seem to be a lot more representative, items that, really kind of clue us in to what other items are. So oftentimes you'll hear someone say, oh, I need a Kleenex, right? Where, Kleenex or Puffs or those kind of things, those are just brands of something that we might use to blow our nose, right? But we kind of, those are representative of the category. Or, for example, when someone says, oh, man, I really want a Coke, that could mean that person wants a Coca-Cola beverage, or maybe they want just a carbonated beverage of some kind. And so, again, these concepts, these prototypes become kind of more and more updated as we go through life, but you can see again how we can kind of develop these. Now, not everything is going to be easily fitting into our prototypes. Sometimes our prototypes can be too limited. So when we think of something like the idea of a bird, for example, we often think of probably that feathered flying creature that has a beak and has certain other features, tail feathers and all that. And then whenever we think about something like a penguin, right, or an ostrich or some of those things, what we'll realize is that those aren't necessarily perfect prototypes, and sometimes that'll get us a little bit confused there. So, again, these kind of mental concepts that we create, these prototypes that help us to kind of understand things a little bit quicker, are good for the most part, but they can be a little flawed if we're not careful. Most of the time when we're trying to solve problems, we use algorithmic thinking, where basically this is a kind of very straightforward process where we come to a solution by using the same steps each time. That whole a squared plus b squared always equals c squared. In the same way, when we go to put on a pair of pants, or the way that we kind of get from A to B in our house, right? We can use that same kind of algorithmic process to come up with a solution. And the more we're familiarized with it, the more we kind of have done this process over and over again, the more that we can actually almost do this whole process without even having to think about it. It's kind of like the idea of driving to work and then all of a sudden realizing, I don't even remember the drive from home to work. All right, that's a fascinating idea that I could somehow just miss that. Heuristics is another way that we can kind of come up with easy solutions to things. So something like an availability heuristic is where we have a basic understanding or concept of something, like, for example, when we think about the likelihood of something occurring. For example, if we think about the likelihood of us winning the jackpot, right? If no one has won a jackpot in a long time, and us playing the lottery might make us less likely, or we have a less available heuristic of that event, so we start judging that as less likely to happen. But let's say someone just won the lottery, or maybe a couple of people have won the lottery in the last few years, then all of a sudden that availability heuristic is now like, wait a second, the probability of this happening again is much higher, right? When in reality it isn't. But again, we kind of use that to help us make decisions. If we think about something like I don't know, driving in a car versus flying in a plane, most of us think about safety. And what's really interesting is that we don't get nervous when we get in our car and we drive from home to work, or even take road trips from here to Dallas. But at the same time, when we get on an airplane, we notice this tension, this worry, like, oh my gosh, like the likelihood of us crashing and and all those things it just seems so much more probable. And it's just such a weird concept, because statistically we're 100 times more likely to die in a car accident than we are to die or even get injured in a plane crash. Yet the reason why we seem to have a stronger availability heuristic with something like that is based on how publicized such events are, right? If a plane crashes, you're going to hear about it on the news for months and months, and it's going to be very kind of intense. It's going to be very like a lot of life lost, right? But when there's a car accident, when there's those things, right, it happens so frequently that it doesn't get the same kind of news coverage or reporting. It doesn't get the same kind of big media attention, and so as a result, our availability heuristic kind of is reduced on that. And then we have our representative heuristic, where we kind of take information, maybe something that we know about a group or category, and we just kind of think that applies to everyone who kind of what we feel like meets that category. Like, so if this person kind of seems similar to someone else I know, then I kind of use that kind of representative heuristic to say, well, that person must like the same things that other person likes. Or it could even get a little bit further if you really want to get into things like race or political parties or whatever, right? We just kind of say, well, we'll see how closely we see this person. It's just assume, right, that they're going to have these other interest, qualities, and behaviors that are similar to other people in that same kind of grouping. And again, I say a lot of these with kind of almost a critical perspective, because it's like, well, that could lead to prejudice or other behaviors. But what I'm really trying to get at is that, these processes are actually can be quite useful, right? In your day-to-day life, you can kind of easily categorize the likelihood of something happening, as far as when you're walking up to your car on a bright sunny day, the likelihood of you slipping and falling on ice is very minimal, right? Whereas when you're walking up to your car and there's snow outside, you might have that availability heuristic says, people fall on snow and ice, and we're a little bit more tedious and careful. It helps us, and we make quick decisions that way, as well as using those kind of representative heuristic. Oftentimes we can kind of get an idea of people based on brief things, and sometimes those can be actually fairly accurate. Problem solving. So this is where we're looking at the steps and kind of rhymes and reasons and the things that we use to help us come up with solutions. All right. So we talked about the way we kind of come up to a problem and how we solve it. So we just go through the three basic steps: preparation, production, and judgment. All right. And so in preparation, right, one of the things that we really look at is how much information do we have about the particular problem. So a well-defined problem, right, gives us enough information to come up with a clear answer. An ill-defined problem, right, is where things are either we have too little information, right, where we really are, things are vague and we're not able to see a clear presentation, or on the opposite, we have too much information and now the answer just seems less obvious, right? And so that's an ill-defined problem, right? Now we can run into lots of different kinds of problems. We have problems of arrangement, problems of inducing structure, and transformation problems. And so to give you a quick look at what those are, right, you can see right here we have 3 different styles of problems here. I'm going to get my little point. Oops, sorry, let's go back. We'll get my little pointer down here. Okay. And you can see, for example, in this first category, we have problems of arrangement. So you can see we have a series of letters here, right? And these series of letters, right, when they're rearranged, they create an English word. All right, and so if you rearrange this first one, for example, it'll create doubt, right? And you can see there's some others here. I'll let you work at those on your own, and then you can look at the answers as we can move on. Here again, we're having to kind of arrange things in a certain way to figure out how we can get this string and this string to connect with just these objects down here at the bottom. Problems of inducing structure, right here you can see that we're kind of gonna, based on what happened before, we're gonna guess what's gonna happen next. So 1 4 2 4 3 4 4 4 5 4 6 4. We can very easily say 7 4, right? That would be the next in a series. Completing analogies, something like baseball is the bat as tennis is to, right, racket, right? Because you can use the previous information to determine what's going to happen next. And then down here we have our transformation problems, where we'll take something like a jar. We have 3 different jars right here, each one having a different capacity, right? Then we kind of ask a question like, how do you measure 11 ounces? And so we might look at this in a very straightforward way, whereas if I can only use each jar one time, that would make it much more difficult. But what if I could use jars a little bit more freely? What if I could manipulate things in a certain way to allow me to solve this problem? So, for example, what if I filled this jar, right here, jar A, with 28 ounces of water, all right, and then I emptied it one time into there? What would that give me? That would give me 23 ounces of water, right? And if I emptied it into there again, right, what would that give me? That would give me, right, 18 ounces of water, right, left in jar A, and then I can take jar A and pour it one time into jar B, and then I'll be left with exactly 11 ounces, right? And again, here's another little brain teaser, and you can work these out for yourself on the slides. I just wanted you to be able to see, again, how in the first one we're arranging things in a certain way to find the solution. This one we're using our past reasoning or the information we have collected so far in order to predict the future, and inducing structure, and then finally transformation problems where we're having to take things and maybe use them in a slightly different way. Here's some of those answers for you. And so sometimes in problem solving we'll use a method called means ends analysis, right? So we're, just so you know, we've kind of moved past the first stage, right, which was preparation. Right now we're in the production phase, right? We're coming up with potential solutions. So if I were to move backward again, right, preparation right here, production, and then judgment. Okay, so we're in the production phase. So means ends analysis means that we're going to we're basically going to kind of look for what is the easiest, what is the most straightforward kind of means of accomplishing a task, and we'll try several different methods, and then we'll find the one that seems to be easiest or shortest, right? That's a very basic method that a lot of people will use when it comes to this, right? For example, if I can if I can kind of work out a way to, let's say, open up a box using 10 steps, and then later I try a different method and it only takes me 7 steps, for example, then I'll say, oh, well, I'll just use the 7-step model, right? That kind of means ends analysis. After doing that, shows me that this one is lesser steps for the same result. This category also involves sub-goals, so we break down tasks into smaller, more bite-sized tasks, right? That whole idea, how do you eat an elephant, right? One bite at a time. And judgment, in this phase, this is the third kind of piece here, right? When it comes to problem solving, right? Where we're then going to evaluate the potential solutions that we came up with, and we're going to determine which one seems to fit. Now, in most cases, if we can find a clear one, obviously that's the one we'll stick with and we'll go with using those basic solutions that we talked about earlier. However, sometimes if it's not as concrete, that's where we kind of come up with indecision and we have difficulty solving a problem. Now, some of the most common reasons why we have trouble solving problems is we'll get into what's called functional fixedness, meaning that we will only think of something in its regular, typical use, right? So if, for example, someone tells us to, build a pyramid out of, the chairs that you have in your room or in a classroom, right? Someone who has functional fixedness will only think of chairs as standing upright. They won't be able to think about it, stacking them on their sides or turning them upside down or whatever, right? That's a lack of ability to kind of think outside the box a little bit there. A mental set is where you will have a tendency to try to use old or previous methods of solving problems, and so a very common one I see all the time is the adult temper tantrum. Adult temper tantrum, is basically where I'm trying to solve a problem and I can't seem to get the solution I want. So when I was a kid and that I couldn't get a solution I want, well, I just threw a temper tantrum, right? You see what I mean? Like it's going back to an old way of trying to solve problems. Now, sometimes we can get ourselves into a logical fallacy or just get ourselves kind of so determined to see the solution in the way we want to see it that we can get into what's called confirmation bias, right? But this is basically where we're trying to solve a problem, and the problem that we kind of run into, for example, let's say I want to prove my hypothesis that all birds are white, okay? And so I will, kind of go, well, let me walk outside and look for a white bird. And I walk outside, I see a white bird, and I go, well, there you go. I just confirmed my theory, right? Which, if you think about that, that would be a bad scientist. But what if, on the other side of that, we said, instead of trying to confirm my theory, what if I tried to disconfirm my theory, right? I walk outside and I look for a black bird or a red bird or a blue bird, right? That is a much healthier way of problem solving. And so here again, you can see this first form of problem solving is that confirmation bias. I look for anything that seems to prove the point that I wanted to say, sometimes even ignoring contradicting information, right? Ignoring other facets where I can actually see the problem from someone else's point of view.